Thanks, and I'm really pleased to actually come talk to folks here today. I appreciate the invitation. It's an audience that we're actually really interested in engaging with, although we haven't all that much in our project. So I work in a team of about 8 or 10 people. We sort of came to this waste issue from the perspective of plastic in the ocean impacting wildlife. And so that's the sort of lens I'll talk to you about it through. But we've ended up following that into kind of drivers of litter and hotspots for littering and illegal dumping and looking at flows through wastewater systems and all sorts of other things. We're just about to try to do essentially a waste budget going into the ocean across Asia, so essentially from China to nearly the coast of Africa. So we're interested and we'll be active in this space, and we'd be really interested in engaging with industry folks. So I'm really going to talk about a little bit about our program. So we kind of come to this problem, sort of waste in the environment and its impacts, from a risk framework. So we're really thinking about 4 things. Essentially, what are the sources and drivers? What's the dynamics and the distribution of that material in the environment? Impacts, so that goes everything from wildlife to economics, and then management responses. And so I'll talk a little bit about some work on the CDS we've done at the end. So it's a pretty broad remit, and we basically cover everything from sort of human behavior to statistics and physics. And our real goal is to understand the problem and then present some solutions back from an information perspective. So I'm hoping to talk about 3 main questions today, or I'm planning to. Anyway, we'll see if you understand, if I'm clear. What's the relationship between stuff that's in the marine environment and nearby sites? Can we figure out something about the sources and pathways? And then we've been working on a big policy analysis across Australia and in the US. And I'll just talk a little bit about the CDS in that respect. So sources and drivers. So most of the stuff comes from land, from the perspective of what ends up in the ocean, or rivers for that matter. About 80% of all that is from land. That's the current estimate. It's probably an underestimate. It's probably nearly all from land. There's a recent paper we were involved in that suggests about 8.4 million tons of plastic solid waste goes into the ocean a year, and essentially that's predicated on losses from the waste stream. So that's a sort of global estimate. And we understand a fair bit about where it is at sea. So this is a map based on some oceanographic models and quite a big data set from sampling at sea. And more or less it ends up in these sort of circulation places in the global oceans. So those are the oceanic gyres, they're called. Basically the currents circle inward and it concentrates floating things. But you also see quite a lot in coastal zones where there's big amounts of loss from the coast because of the mix of waste infrastructure and people. So the estimate is there's something like 250,000 tons of plastic floating around in the ocean's surface at the global scale. So the first thing I want to talk about is a little bit about kind of sources and distribution. So there's this sort of fundamental argument going on at the moment in the scientific literature around this stuff, because we think there's about 8 million tons going in a year, but when we add up what we can account for in the ocean, there's only 250,000 tons there. So there's sort of, about 40 times, if I do the math right, what's going in each year is about 40 times what the total amount in the ocean is. And it's unclear why that mismatch is happening. So it's probably because a lot of that's being driven up on the shoreline. So here's a picture of a typical shoreline in a place where a lot is being driven on shore. And this is a picture of what you typically find in the ocean. So that's from one of our sampling nets. So the first thing you notice is that stuff's a lot bigger than this. So some reasons why that mismatch might be happening. It could be most of it's getting trapped in the shoreline. So this assumption that everything goes to the ocean is wrong. It could be things are heavy. So a lot of the polymers are actually negatively buoyant and would sink. So you'd mostly find them in estuaries, or maybe they don't even make it out of the drainage systems. And I guess the third thing that's going on is most of the forcing in the marine environment actually comes back on shore. So waves and winds primarily drive things on shore. So one of the things we've been working on lately is trying to resolve this essentially mass balance. And over the last few years, we collected a data set of debris, plastic along the coastline at the continental scale. So all these little red dots show you places we've sampled, and we use this sort of standard method. And sometimes we have school kids work with us. And from that, we made an estimate of how much is on the coastline, relatively speaking. And this is once you take account of things like population and stuff like that. So from that, we can think about transport on shore. So there's something like 6.4 items on the coast per person in Australia. And those are big items. If you count little bits, there's a lot more. So there's this question of why do you get this hotspot here and why do you get a hotspot there, and you get one here. And that's even after you take account of population. And if you look at the oceanography, it kind of explains the issue to some extent. So here's wind velocities in Australia from the bomb, and what you see is here and here, there's quite strong winds, and those are prevailing from the west, so basically driving everything on shore. So that probably explains the high spots there and there. And if you look at this map, this is from an oceanographic model, and the kind of hot colors show you where ocean currents would take things. And what you see is stuff just wanders around off Perth, and it kind of wanders around off Darwin. But if you look at the east coast of Australia, it basically gets entrained in the current, comes down the coast, and then goes off here. And stuff coming from Melbourne is essentially doing the same thing. So more or less, if you live in this part of the coast, you're getting sort of the flow from everybody north of you as it's all traveling down. So that sort of explains that pattern. So that's a kind of a rough thought about kind of how the stuff's moving around. What we got interested in is the way people are modeling this stuff. They simulate bits of plastic leaving the coastline based on how many people live there and waste infrastructure and a bunch of other things. And from that, they construct plumes at sea. And we wondered if some of these plume models people are using are actually correlated with what we find on the coast. And the crux of our question was, could we work out how much of the stuff that's coming out of cities and things is actually escaping to the ocean and how much is getting transported back on shore? So we used one of these plume models from this guy, Le Breton. That's a nice young man, lives in New Zealand. And what we did was we counted up all the particles in his plume model that ended up within 8 Ks of the coast. And what you see is, even if you look for a long time out after the particle's been released, it's still pretty close to the coast. So this is the count of particles, the time since they are released, and the amount, in this case, that are in the coastal zone. And this is sort of how far they go based on these oceanographic models. So essentially it says almost all the particles stay close to the coast, and they actually stay relatively close to the source. So the plume around Sydney effectively is probably only a couple hundred Ks. And that was something we sort of saw in our coastal survey data. So around 90% of the particles are still within the littoral zone, so that's kind of the surf zone plus a little bit, even after a week from this model. And so this is what the model says, this plume model, what the coast should look like in terms of how dirty it is. So the bigger the circle, the more dirty. And essentially this is what our data says. So our data says this should be high, this should be somewhat high but lower, and the model, the plume, is saying this should be much higher than that. And so the resolution to that is thinking about the onshore transport in the coastal zone. So we did some modeling, and essentially if you take account of what's called Stokes drift, which is waves moving things, and wind, more or less you get quite a good prediction of how much we find on the coast. So essentially the upshot of all of that is what you find on our coast is ours. And not only is it ours, it's probably from a source within 100 Ks or so of where you're actually at. So that's just summarizing it. I'll skip ahead to the next thing. So one of the other things we worked on, we got some money from the Packaging Covenant to put together the national data that we could lay hands on litter on shore and try to build a model to work out what the drivers are of high amounts of sort of litter and illegal dumping. And this is just a picture of all the data we were able to put together. So we had 3 sources: Clean Up Australia, Keep Australia Beautiful, and our own data. And the dots show you kind of where the data is at. And we had a crack at looking at a bunch of things. So effects of urbanization, some stuff on land use, socioeconomics, and then a sort of site type. So, are you in a parking lot? Are you in a shopping mall? Where are you exactly? And interestingly, a lot of those things were actually quite informative about how much litter or illegal dumping is happening in a place. So people tend to throw the most stuff in anything that is made of water. Creeks, wetlands, things like that. Disused grazing land comes next. And people don't throw things in essentially conservation reserves. We saw a big effect of site types. So this is from the Keep Australia Beautiful data. And they keep track of whether they're in a car park or on a highway or in a residential area. And there's quite a lot of difference. And essentially the takeaway message is that places where people are transient, so highways are the worst. Littering or dumping rates are really high. And places where people aren't transient, like residential areas, they're relatively low. And the aesthetic value seems to matter. So if something is signposted, so an abandoned lot versus a park that look ostensibly exactly the same, just the fact that there's a sign that says park seems to affect people's behavior. And the last bit is the strongest predictors of both dumping and littering were essentially socioeconomics. So it had to do with, it increased in areas with high poverty, it decreased in areas with high employment, and it decreased in areas with high education. So ultimately, it kind of gives you some guide as to where you might target policy interventions, be they more infrastructure or they be outreach campaigns. Ooh, that's exciting. Yep. So we've done this sort of work in Australia, and we've also done it in the US. The US has quite a big data set that we analyzed. And we're at the place now where we can make sort of continental scale predictions of load. We can also make predictions for a specific site with given conditions. So if you want to know about neighborhood X in place Y, we could actually tell you. So how much plastic we'd expect to be on the land surface there. So this is just some estimates we made. We did a similar thing to what we'd done in Australia. We estimated the amount of plastic on the US coastline, and depending upon which estimate you use, there could be up to 1.8, I think that's trillion, items of greater than 1 centimeter size on the US coastline. Okay, I'll talk briefly, this is going to be like a whirlwind tour, about some work we did in Brisbane. So we're trying to estimate, we know a fair bit about the ocean. What we're trying to do is think up sort of stream to what's on the land surface and how does it move into the ocean. So we did a project in Brisbane looking at flows across the landscape, and we divided the whole watershed of the 3 rivers in Brisbane into 300-meter grid cells. So it's about 100,000 square kilometers. And we looked at wind and water transport of litter loads across the surface. And we were able to use these models to make a map like that. So that's the predicted load that you'd find in every 300-meter grid cell in 3 Brisbane watersheds. And then we took a map like this, which is essentially the water flow across the region, and we asked, can we predict what we would see at a given location where we have data, given how much load we think is up in the watershed and the movement. And so it turns out we can find some predictive models. Essentially, the most important thing is people dropping it. So about 60% of the pattern in what's in a place is direct deposition from people. Second to that appears to be water transport. So, and it's affected both by the volume of water coming through and the amount of load above you. So as more water comes through, stuff gets flushed past a site and the load goes down. But as there's more load up higher in the watershed, there's more stuff coming. So there's an increase. So there's a sort of complex relationship with water. And then wind basically transports stuff, but about half as important as water. So more or less it says if you're thinking about where to put infrastructure, you could use these predictions and basically work out for any creek, storm drain, whatever, how much load you have, and you could evaluate the infrastructure there and work out how much you'd expect to catch or not catch. Lots of talks about plastic in the ocean are full of despair. And so I wanted to show you this image. So I work a bit in Jakarta, not so much on plastics at the moment, but on illegal fishing. But we're doing a bit of stuff on plastics there. And so this is a photo someone's holding of what this river looked like before the mayor of Jakarta implemented a cleanup program. And this is the same location afterward. So basically, they have an employment program for low-income people, and they put in a bunch of infrastructure and spent some money dredging and stuff, and they were able to turn that into that. If you can do it in Jakarta, where there's no waste infrastructure to speak of, I think you can do it anywhere. So that's my message of hope. We've been thinking about, we give a lot of policy advice from the UN level down, all the way to sort of local governments. And we've sort of come up with, at least from a risk assessment perspective, this picture. So essentially, if you're thinking about impact, that goes from human death to what's called existence value. So how nice does the beach look to you? And there's sort of monetary and non-monetary values in between that. And then you can think about how much coercion is the public, sort of government or society, willing to apply to a problem, and then the strength of evidence. And so essentially, as the strength of evidence goes from possible to established, and then generally the amount of coercion society is willing to apply goes from compelled to voluntary. So, we don't allow people to fire handguns in the middle of cities because it's a high chance of human death, and it's very certain, right? We kind of allow people to smoke, although we discourage them because there is some certainty about bad impacts, but it's not one-to-one. It's not like getting hit with a bullet. So I think this is a useful frame for thinking about how we approach the plastics stuff from a regulatory perspective. So this is a volunteer pulling a straw out of a turtle's nose. These guys spent like 6 hours pulling the thing out. And that's at one end of this spectrum, where we're essentially down here. There's low evidence of an impact. It's hard to connect the turtle to that thing in any population way that's connected to policy. And so volunteers do this sort of stuff. And we don't really compel anybody. An interesting, contrasting example is Ghana. So Ghana had a big flood, I believe, last year. 11 people died, and one of the major drivers was essentially all the stormwater drains were clogged with solid waste, a large fraction of which was plastic. The president of Ghana basically banned any plastic less than 20 microns, possession, production, sale, or distribution in the whole country. Just bang. So that's at the other end of the spectrum. This sort of thing, I think, has happened in terms of whole bans of thin film plastics has now happened. I believe it's 5 or 6 countries around the world have done it in varying depths. So I just want to frame that before I talk about container deposits. So we did a little work on container deposits. This is the US, and here is, in black is states with the container deposit present, in gray, not present. This is the number of drink bottles that would attract a deposit in the waste in the environment from cleanup data. And what you see is states with a CDS have way less bottles in the environment. People could argue that there's lots of other things that could affect that. So what you could do is look at the ratio of bottles to lids in the environment, because bottles attract a deposit, lids don't, they come together. So if the ratio is different, that suggests that CDSs are affecting the ratio of bottles. So there's bottles to lids. There's lots more lids per bottle in places with a CDS than without. So that's US data from 6 states. Here's Australia. So there is South Australia, lowest fraction of beverage containers in waste from coastal cleanups of any state. Second to NT, which I believe has some amount of a deposit. And if you look at the lid thing, you see the same picture. The ratio of lids to bottles is super high in South Australia in the NT. So the letters tell you which are statistically different, but you can kind of see from the bars essentially. So I present that just by way of saying I think the CDS discussion has moved quite far, but the evidence for effective policies, be it CDS or other things, is unambiguous, I think. So I'll just leave you with 4 take-home messages. I think one, most impacts from the marine environment perspective are local, and stuff moves more in the marine environment than on land. So essentially the solid waste in the environment problem is a very local problem, which is good because that means both policy responses and benefits are local, which makes the economics easier. There's definitely effective policies. The evidence for the CDS, I think, is completely clear. I think this idea of putting models together with data is useful for answering questions at scales that are hard otherwise. And finally, I think we've benefited a lot from our interactions with industry, and I think that's key in going forward, both at the producer end and at the collection end. So with that, I'll close, and I'd welcome anybody that's got data that would like to share it.
Thanks, Chris. That was great.
Cheers.